Welcome to doassignment-ca. Here is the problem. The speed of a train during the first minute has been recorded at 4 moments. At time 0 seconds, the velocity is 0 meters per second. At 20 seconds, the velocity is 16 meters per second. At 40 seconds, the velocity is 21 meters per second. At 60 seconds, the velocity is 24 meters per second. Approximating the VT curve as straight line segments between the given points determine the total distance traveled. Now let us work through the solution step by step. When velocity is given at discrete points and we connect them with straight lines, the distance traveled equals the area under the VT graph. For each straight line segment, the area is a trapezoid, 1/2 times the sum of the two velocities times the time interval. We will apply this formula to each of the 3 time intervals. We have 4 data points: time 0 with 0 velocity, time 20 seconds with 16 meters per second, time 40 seconds with 21 meters per second, and time 60 seconds with 24 meters per second. This creates 3 equal intervals, each spanning 20 seconds. Plotting the 4 points and connecting them with straight lines, the slope of each segment represents the average acceleration. The acceleration is 0.80 meters per second squared in the first interval, then drops to 0.25 in the second, and further to 0.15 in the third. The train keeps speeding up, but more and more slowly. For the first interval, from 0 to 20 seconds, the velocity goes from 0 to 16 meters per second. Since one side is 0, the trapezoid is actually a triangle. The area is 1/2 times 16 times 20, which gives 160 meters. For the second interval, from 20 to 40 seconds, the velocity rises from 16 to 21 meters per second. The trapezoidal area is 1/2 times the sum of 16 plus 21 times 20. That is 1/2 times 37 times 20, giving 370 meters. For the third and final interval, from 40 to 60 seconds, the velocity increases from 21 to 24 meters per second. The area is 1/2 times 21 plus 24 times 20. That is 1/2 times 45 times 20, which equals 450 meters. Adding the 3 areas together, 160 plus 370 plus 450 equals 980 meters. The train travels a total distance of 980 meters during the first 60 seconds. We can verify by applying the trapezoidal rule as a single summation. Taking the average velocity over each interval and multiplying by 20 seconds, 8 times 20 is 160, 18.5 times 20 is 370, and 22.5 times 20 is 450. The total confirms to 980 meters. To summarize, the first interval contributes 160 meters, the second contributes 370 meters, and the third contributes 450 meters, for a grand total of 980 meters traveled over the first 60 seconds. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.